Good morning, Honors Algebra 2. It is Wednesday, April 29th, and we are continuing on talking about permutations in section 15.6. Before I teach the lesson, I want to go ahead and show you a couple of things on the calculator. One you've already seen before, and that is where do I find the command for factorial? All right, so let's just go ahead and try to calculate what is 5 factorial, which if you'll remember, 5 factorial is 5 times 4 times 3 times 2 times 1. We learned that back when we were talking about the binomial, I think it was the binomial theorem. So anyway, so let's go to math. I hit in the 5, then I'm going to go to math. Now you can go to the right 3 clicks to probability, or you can go to the left 2 clicks. And we want to go down to number 4 and choose the factorial key. So 5 factorial, it will calculate for you 5 times 4 times 3 times 2 times 1. And I'm going to go ahead and enter. It is 120. Now, the other thing we're going to do is we're going to learn about permutation today. And I'm going to explain this to you later, but for right now, know that when we do a permutation, you're going to pick a number, like let's pick a 6. Everybody enter in 6. Go to math. I'm going to click left 2 places to go to probability this time. Notice choice number 2 says NPR. This is not National Public Radio. This is a permutation of N objects, and we're selecting R number of objects to order. And I'll explain all that in a minute. But we've already put in a number, and now we're going to select number 2. So we have a 6 and then a P for permutation. And let's go ahead and put a 4 here. And so just know that that's how you're going to do it. I'm going to press enter, and my answer is 360. We'll learn what that means right now. So let's go back. I'm going to stop sharing now, and here I am. So let's go ahead and look at what is a permutation. It is an arrangement of elements in a definite order. Now, what do I mean by that? Well, let's look at this example. How many ways can we order the digits 1, 2, and 3? All right, well, I've put all the ways we can do it. We can do 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Those are all the ways that I can order the digits 1, 2, and 3. And there are 6 ways to do it when you count those 6 different 3-digit numbers, okay? So I have 6 ways of doing it. Now, isn't there an easier way? You betcha. Okay, and so that easier way is this. Think about the fundamental counting principle, okay? And the only thing different about this is with the fundamental counting principle, we were doing like how many different license plates can you do? Let's say you had 3 different letters. It would be your choices are 26 letters times 26 letters times 26 letters. Well, we could repeat the letters. Here, we're not repeating the number 1 or the number 2 or the number 3. They're only allowed to be there one time. So that's the difference. Now, let's look in the first slot. The first digit, I had a choice of 3. Well, if I have a digit in the first position, then that's going to only leave me with 2 choices for the second position. If I have used 2 digits in the first and second position, that will leave me with 1 in the third position. And so now I have 3 times 2 times 1 is 6. And that's my answer, isn't it? Without having to write it all out. I have 3 digits. How many ways can I order them? Well, that's really 3 factorial. 3 times 2 times 1. Okay? If I wanted to order 10 digits, it would be 10 factorial. If I wanted to order 100 digits, it would be 100 factorial. Okay, so let's try another problem. Find the number of permutations of the 4 letters P, Q, R, and T. Well, how many things am I putting in order? 4 things. And so my answer is simply 4 factorial. Let me go ahead and see what that is. 4 factorial. I'm going to enter in a 4 and then do math and go over to probability. And I'm going to hit number 4. And I have 24 ways. So there are 24 ways for me to order those 4 letters. Okay. Now, let's make it a little bit more complicated. What if I have the letters in the word justice? So I have 7 letters. But the question is, in how many ways can the letters in the word justice be arranged using only 5 letters at a time? I'm only going to use 5 letters. Well, let's use the same system we used before. I've got 5 slots here instead of 7. So this answer is not going to be 7 factorial. Let's see what it's going to be. Well, my first digit, I have 7 different letters to choose from. In the second position, I'd have 6 because I've already used one in the first position. Then I'd have 5, 4, 3. So what I have here is 7 times 6 times 5 times 4 times 3, and I stop here because I only am choosing 5 letters. I can't go on to the 6th and 7th slot. So that number, I've already put the answer here, 2,520 ways I can arrange 5 of these letters. Now, let's look at how that could be calculated. I could start with 7 factorial, the total number of letters I'm choosing, and divide it by 2 factorial. Because if I divide it by 2 factorial, what's going to happen is my 2's and 1's are going to cancel out, and I have 7 times 6 times 5 times 4 times 3. That's exactly what I have here, okay? Now, how can I write that? Well, it's really 7 factorial divided by 7 minus 5, which is 2 factorial. 7 is the total number of letters I have to choose from. 5 is how many I'm actually choosing. So the total, 7 factorial, divided by 7 minus 5 factorial, the total minus how many I'm going to choose. Now, we can formulate a general formula for permutation from that idea. So let's look over here. Okay, now in the previous problem, wrestling with the board. Okay, in the previous problem, we had a permutation of 7 letters. We are only choosing to arrange 5 of them. So permutation of 7, choose 5. And we know it was 7 factorial over 7 minus 5, the difference factorial. Well, here is my general formula for a permutation. N is the number of total items I have to arrange. R is the number I'm actually going to arrange. So the formula is it's N factorial over N minus R factorial. Now, what if I'm going to arrange all of them? Well, let's just say this. Let's say we have 4 letters and we want to arrange all of them. Does that still hold up? Well, let's check it out, okay? So that would be 4 factorial over 4 minus 4 factorial. I'm following my formula here, which would be 4 factorial over 0 factorial. Well, I don't know if you remember this way back from the binomial theorem, but 0 factorial is defined to be 1. And so just arranging 4 letters or numbers, and you're going to arrange all 4 of them, that it is 4 factorial, which we did on the flip side, okay? So the formula still holds up because 0 factorial has a value of 1. Now let's do something a little bit more complex. Let's use our formula here. From a set of 9 books, 4 are chosen to be arranged on a shelf. So I've got a total of 9 objects. I'm only going to arrange 4, and I want to know how many ways they can be ordered on the shelf, how many arrangements are possible. So here's a permutation of 9. I'm choosing 4. I'm choosing 4. Now you may use your calculator. Okay, now on your quizzes and your tests, you will have to also know this formula. You don't have to memorize it because everything is open book. But what we're really calculating here is 9 factorial over 9 minus 4 factorial, which is 9 factorial over 5 factorial, which is really just 9 times 8 times 7 times 6. Okay, now let me go ahead. If you want to, go ahead and practice with me, and let's go ahead and enter in the 9 on our calculator. Let's go to math. I'm going to go over to probability, and I'm going to choose number 2, my NPR. So I have a 9, choose 4, and I'll get my answer. I'm getting 3,024, okay? If you wanted to, you could also do 9 times 8 times 7 times 6. And I'm getting the same thing. Look at that, 3,024. 2 ways to think about it. Okay, now last thing we're going to talk about is a distinguishable permutation. Okay, now I have the word bib. Okay, I've got 5 grandbabies now. We use bibs. Okay, now, how many distinguishable ways can I order these 3 letters? Now, 2 of them are the same, which makes it a little complicated. Okay, so I could use BIB, but what if I switch this B and this B? Would it look any different? No, it would still be BIB. And so I can't distinguish between BIB and switching it and making it BIB. It still looks like bib. All right, my next option is BBI. Now I could switch these 2 B's, but they look the same. So it's not going to have any distinguishing thing about it. I'm not going to be able to tell the difference between BBI and BBI. Same thing here, IBB or IBB with the BB switched, okay? If one was green and one was yellow, yeah, I could tell the difference. But if it's all just printed in black and white on the page, I can't tell the difference. All right, now, so what do I do when I have repeating elements? We call them elements, okay? In this case, it's letters. Well, what I do is this. I start with my 3 letters, okay, three objects to arrange. I put 3 factorial in the numerator. In the denominator, I'm going to do a factorial, and this number will be the number of repeating elements. In this case, I have 2 B's, and so I'm going to put a 2 factorial over here. And let's see if we get 3 distinguishable arrangements like we did when we just wrote them out. Well, 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. What do I get here? Boom, boom, I get 3. Okay, now let's do it with another word. How about the word hubbub? Okay, now we've got more repeating letters here, so what are we going to do about that? Well, let me show you. Okay, so let me go over here, and I've got how many letters first? 1, 2, 3, 4, 5, 6. I've got 6 factorial, okay? In my denominator, let's first look at what repeats, the U's repeat. I have 2 repeating letters here. That's going to be 2 factorial. How many other repeating letters? I have 3 B's. So I'm going to list that. 3 factorial. So I have 6 factorial over 2 factorial, 3 factorial. Now you can use your calculator. Let me just do it without it. I've got 6 times 5 times 4 times 3 times 2 times 1. I've got 2 times 1, and I've got 3 times 2 times 1. Okay, so let's cancel out our 3, 2, 1 and our 3, 2, 1. And let's cancel out 4 over 2 is 2 over 1. And what am I left with? I'm left with 30 times 2. I'm left with 60 distinguishable arrangements of these 6 letters. 60, yes, distinguishable arrangements. I can tell the difference. Okay, that's it for today. Permutation. How many ways can I arrange something when the order is important? So I hope you have a great day, and I hope you're enjoying this chapter. It's certainly different than trigonometry, which is a nice change of pace. So come see me at 10. I've been lonely. Haven't seen anybody for a day or 2. So anyway, have a great Wednesday, and I will talk to you tomorrow or see you at Zoom at 10. Bye-bye.